In this video, we're going to look at finding the fluid pressure, the force of a fluid against a surface. And what we have now is a dam that is 60 feet across and 25 feet high. This is just rectangular, so this is one of our more basic cases. But let's just talk about a little bit about the way this works. What we do is we like to look at a slice right there. And we're going to look at the force on that slice because everything on that slice is at the same depth. So let's give it a thickness of delta H. And so what we might do is initially look at the force on that ith slice. Well, that's going to be the amount of pressure times the area of that ith slice, which is 60 by delta H. And we can measure the depth from the top or the bottom. So let's say H sub I is this way just to make it a little easier. So that's now our depth. So the force on the ith slice is delta H sub I times the area, which is 60 delta H. So here we got the pressure, which is the amount of pressure on some single point, which is the depth times the density of water, and then multiplied by the area will give us the total force on that ith slice. On that ith slice. So the total force is going to be the integral of delta H times 60 dH. And now we just do it over the total depth of the water, which goes from 0 to 25. And we've got our definite integral. So we've got 60 delta times the integral from 0 to 25 of h dh. So we end up with actually a very basic definite integral. So h squared over 2 is the antiderivative from 0 to 25. And we end up with 60 delta 25 squared over 2. We don't have to worry about plugging in the 0 because it's just going to zero out. And we can now put this into a calculator at this point. We have all our numbers. We'll put it in exactly how it's written. So 60, I'll include my delta, which is 62.4 times 25 squared divided by 2. And we see that we are going to have, see that there, equals 1,170,000 total pounds of force. So we're looking at a force now, so the units are pounds.